An industrial explosion doesn't start with fire. It doesn't start with alarms or people running. It starts in silence, somewhere inside a refinery, a power plant, or an offshore platform. A metal component fails without anyone noticing. No noise, no warning. But at that moment, the disaster is already set in motion. Here at Factory Manufacturing, we unveil the secrets behind the fabrication of products you use every day. From microscopic components to gigantic machines, we show how engineering and technology unite to create the incredible things that move our world. If you're passionate about industrial processes, manufacturing, and technological innovation, you're in the right place. Subscribe to the channel and hit the bell icon so you don't miss any video from our journey through the fascinating world of industrial manufacturing. Get straight to the point. In heavy industry, danger doesn't come from what moves fast. It comes from what looks too stable. Every day, absurd amounts of energy move invisibly across the world. Crude oil traveling through kilometers of pipelines. Natural gas compressed under extreme pressure. Superheated steam capable of deforming steel. None of this is standing still. None of this is harmless. And yet, everything appears to be under control. The reason is simple. There is an entire system dedicated to deciding when this flow continues, when it slows down, and when it must stop immediately. That system is not digital. It is not intelligent. It has no artificial intelligence. It is mechanical, heavy, and unforgiving. These are industrial valves. They don't appear in advertisements. They're not showcased at technology expos, and no one thinks about them while everything is working. But when a single valve fails, the chain reaction can turn an entire facility into a war zone. An industrial valve doesn't just open or close a flow. It isolates entire sections. It controls pressure. It prevents a system from exceeding safe limits. In many cases, it is the last barrier between normal operation and an explosion. The problem is that this enormous responsibility rests on an object that, to an outside observer, looks far too simple to be so critical. That's why the manufacturing of an industrial valve begins long before any machine is turned on. Everything starts with massive blocks of metal. Carbon steel, stainless steel, and special alloys designed to withstand extreme heat, chemical corrosion, and constant pressure. These blocks arrive at factories with no defined shape. They're just solid, heavy masses with no visible sign of sophistication. But what comes out of them must endure conditions that would crush ordinary components in seconds. A microscopic error at this stage doesn't become rework. It becomes risk. After material selection comes the most critical phase, heavy machining. These blocks are taken to massive CNC lathes and machining centers. Machines capable of removing metal with extreme precision, repeating movements for hours without deviation. Here, the metal is sculpted slowly, millimeter by millimeter, sometimes hundredths of a millimeter. Every surface must meet strict tolerances. Every fit must be perfect. Because a valve doesn't function like an ordinary object. Its parts don't just touch, they seal. If a surface isn't perfectly aligned, fluid finds a path. Once it finds a path, leakage begins. And leakage is never an isolated event. It causes internal erosion. Erosion leads to wear. Wear alters the fit, and the altered fit accelerates failure. That's how systems collapse without warning. That's why during machining, there is no room for improvisation, no close enough. Either it meets specification or it's rejected. Even after machining, the parts still aren't ready to face reality. The metal, as it leaves the machine, is still vulnerable. It needs to be transformed. That's where heat treatment comes in. The parts are taken to industrial furnaces operating at extreme temperatures. Inside, the metal is heated to levels that completely alter its internal structure. Then it's cooled in a controlled way. This process rearranges atoms, increases hardness, improves dimensional stability, reduces the risk of deformation under load. In simple terms, the metal stops being just strong. It becomes reliable. But even then, no one trusts the process alone. Before a valve is considered ready, it must prove it deserves to exist. That's when testing begins. Each valve is subjected to pressures higher than it will ever face in real operation, not for seconds, but long enough to expose any hidden weakness. They are tested for leaks, deformation, and structural failure. Some tests are performed behind physical barriers because if something goes wrong, the energy release is instantaneous. There is no partial approval here, no emotional tolerance. Either the valve passes or it's discarded, even if it's expensive, even if it took hours to manufacture, because in the field, there is no undo button. Once installed, an industrial valve may go years without being touched, operating under constant pressure, exposed to thermal variation, handling corrosive substances. And during all that time, no one thinks about it. It doesn't send alerts. It doesn't ask for attention. It simply keeps everything under control until the day it fails. When that happens, the failure isn't gradual. It's abrupt. The system loses containment. Pressure searches for an exit, and stored energy does the rest. Refineries shut down. Power plants collapse. Entire platforms become high-risk zones. And almost always, after the disaster, someone finds the same point of origin: a valve. These components aren't famous, they aren't celebrated, but they silently support the modern world. Every time you turn on a light, fuel a car, or consume energy, there is an invisible network of valves working to keep everything under control. They don't ask for attention, they demand absolute precision. Because in heavy industry, it's not the noise that kills. It's the silence of something that stopped working when no one was watching. The modern world doesn't depend on massive explosions or impressive machines. It depends on things that go unnoticed. While cities sleep, while industries operate without pause, while energy keeps flowing, there is an entire system working outside your field of vision. Not to impress, not to be seen, but to prevent everything from spiraling out of control. Because in heavy industry, it's not force that keeps everything standing. It's absolute control over what can go wrong. And almost always, that control begins with a single valve, working in silence,